So if a robot or a computer program or AI is able to start writing its own code, at what point would it be able to overwrite or basically nullify the three laws of robotics?
That is a good question.
Well, we just went right to sci-fi. This episode is sponsored by Hired.com. Are you searching for a new job? That could be stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through the interview process just to find out at the very end that the salary, offer, or company culture doesn't match what you're looking for. Hired is the world's most intelligent talent matching platform for full-time and contract opportunities in engineering, development, design, product management, data science, sales, and marketing. We make your job search faster, focused, and stress-free. Instead of endlessly applying to companies and hoping for the best, Hired puts you in control of when and how you connect with compelling new opportunities. After completing one simple application, top employers apply to hire you. And on Hired, you receive personal interview requests and upfront salary information so you can make informed decisions about what opportunities to pursue over a condensed timeline. Hired offers access to more than 4,000 innovative employers, including big brand names like Facebook and smaller emerging startups. The size and type of company you want to connect with is totally up to you. And we help you find new opportunities in 17 major cities in North America, Europe, Asia, and Australia. Open to relocation? Let them know. Your privacy and autonomy in your job search is of utmost importance. And if you sign up today using the show's link, that's hired.com/rubyrogues, you can get double the normal hiring bonus. That's $600 instead of $300. So go check them out at hired.com/rubyrogues. Hey everybody, and welcome to another Ruby Rogues podcast. This week on our panel we have Dave Kimura.
Hey everybody.
I'm Charles Max Wood from devchat.tv. Another quick shout out about Ruby Dev Summit that's coming up in October. So if you're into Ruby, then yeah, definitely check it out. We also have two talks that are related to what we're talking about today. And we have Tyler Renelle here to talk to us about machine learning. Tyler, do you want to say hi?
Hi. Hello, everyone.
Now, I think you're probably the first guest that we've had that's done the trifecta, which is Ruby Rogues, JavaScript Jabber, and Adventures in Angular.
It was Adventures in Angular, JavaScript Jabber. I don't think Ruby Rogues. I don't actually code in Ruby. I gave it a shot once upon a time.
Yeah, well, this is Ruby Rogues, so you're gonna hit it. And
I see.
We were having a conversation. I think it was over email about machine learning, and this is one of those topics that I think kind of goes beyond Ruby. And so I know there are some libraries and some options out there for doing this with Ruby, but anyway, I thought we could just jump in and talk about machine learning and, at kind of a higher level and get some idea around what it is and what it means for people who are out there working in the programming community right now.
Sure, cool. So I'll start by defining machine learning. It's because it's a very different concept than programmers are used to if they haven't been introduced to it. I think of it as like we went through these phases in computing technology. The first phase was just building computers in the first place, but it was hard coded onto the chips. The programs that you built were hard coding into the physical computing machinery. And then we moved on to programmable computers. So you can reprogram your computer to do anything. And that's where we are as programmers. And the next big wave is machine learning, which is the computer programs itself to do something. And so you give it a goal, you give it a task, you give it some measurement of how it's doing based on some data that you're training it on. And it proceeds to train itself and learn how to perform the task. So it's sort of the next wave of computing technology. And there's a lot of people shifting over. It is very popular right now. It's getting a lot of press. One of the big reasons it's getting so much press is it's becoming a lot more capable than it ever has been before by way of deep learning, which I'll talk about later, through innovations in the software technology on the algorithm side, innovations in hardware. So GPUs has made computing machine learning algorithms so much faster. And also the availability of data. So just over time, we've collected tons and tons of data on the internet. And then we realized at some point that we could use all this for our deep learning algorithms. So these three kind of things came together into this perfect storm. And now machine learning is just way more popular, way more accessible than it's ever been before. And so we're starting to see a lot of very large advances in the field, like self-driving cars, image recognition, tag your friends on Facebook, and anything. So let me step back a little bit. What it sounds like I'm describing is artificial intelligence, AI. And machine learning is a subfield within AI, AI being the overarching field of a computer, of simulating intelligence in any capacity, simulating mental processing. The end goal being evil killer robots, of course. And machine learning is a space within AI. There's also, vision. You have to have, the robot has to be able to see. You have robotics. The robot has to be able to move around a space. You have speech processing, NLP, natural language processing, and all sorts of other fields within AI. And then one of them is machine learning, which is the robot should be able to learn how to do various tasks. But these two fields, machine learning and AI, are sort of coming together, merging together, so much so that machine learning is less and less a subfield of AI over time, and it is more the majority of AI. Because now we can apply machine learning algorithms to vision with something called convolutional neural networks. We can apply it to speech processing with something called recurrent neural networks. We can apply it to planning and knowledge representation. This is a whole bunch of stuff that's coming down the pike at DeepMind with things like deep Q networks. And so machine learning is fast kind of subsuming the entirety of artificial intelligence, to the point that people are starting to consider those terms synonymous, artificial intelligence and machine learning. So if you want to get into the space of AI, you're going to start with machine learning. I'll stop there if there's any questions.
Yeah, I guess that's where I sort of got stuck when I first started looking into this was, what's the difference between machine learning versus AI? And it seems like, the two are converging, but there's definitely a difference. It's also interesting just to look at the different ways that we use machine learning. I mean, you mentioned self-driving cars, but I mean, we've had algorithms that learn to play chess and things like that for a long time that essentially were, they would just watch a bunch of games or play a bunch of games against itself and then learn how to do it. And so it's interesting just to see how this all goes. Though I think the connection between machine learning and like self-driving cars, it still feels a little bit abstract, right? It's like, okay, so, I write this machine learning algorithm and then the car can drive itself?
Right. There's obviously so many things at play in the technology of a self-driving car, but one of the very fundamental pieces is machine learning. So, for example, instead of programming a car to drive down roads, you couldn't possibly program every possible circumstance with if-else statements. Mm-hmm. You program it to learn how to fix its mistakes if it goes off course. Or, the way a self-driving car works in the beginning is it's basically you have it built into the dashboard. Imagine it that way. And you are driving as a trainer, and you're making turns and you're stopping at stoplights, and it's observing your behavior. And it's at every point, at every second in the driving process, it's guessing what you would do. And then it's correcting itself if it was wrong, if it guessed wrong. So if you turned left and it said, oh, you're going to turn right, and then it's, oh, okay, so something's up. I need to adjust some parameters in my algorithm. And then over time, it gets more and more accurate. So that's the data you feed to it. In the case of a self-driving car, is your driving patterns. And then it adjusts and adjusts and adjusts. And eventually you have some high accuracy, like 95%. And now it can go off and drive on its own.
I know some people don't want it to learn how to drive like.
Yeah, I'm one of them. I'm pretty accident prone.
But the idea would be if it can feed its, if all these cars can kind of feed each other, then they'll normalize on the average driver across the world, of course. But I don't know how they actually train it on good drivers versus bad drivers. I'm sure they've got some sort of mechanism at play for knowing about road rules and such.
Mm-hmm.
But so I guess that's kind of also another example would be facial recognition, where if you want to compare someone's face, it has to start learning about that person's face over time, I guess building a template about that person. So if they change their hairstyle or wear glasses or a hat, then it'll be able to make an educated guess if that person is truly who they say they are.
That's right. So like through the evolution of machine learning algorithms, in the early days, so much was hard coded, and that's just programming. That's what we do. Over time, we started adding what I call shallow algorithms or classical approaches to machine learning, where in the case of facial recognition, you'd use some stuff like eigenvectors, and it's a lot of linear algebra. But it was kind of like you have to know a lot about the domain. You have to know a little bit about how, images are constructed and what you're looking out for in a face and an image. But the crux of machine learning is statistics. So you're never going to get like if you were to program this, you'd be programming it to look for exact patterns in facial recognition. But once you introduce statistics to the mix, then your face can be off by hair or a hat. So we started adding these statistical models to in code, and that's traditional machine learning. And it can start having some small amount of variation that won't throw it off. And then now we're in this world of deep learning. And what that is these classical machine learning models like logistic regression and support vector machines. You combine those all together in a stack, like a layered logistic regression units, what's called a neural network, which is a very popular term. And then now your machine learning algorithm can use these statistical equations to hierarchically divide whatever it is it's looking at, whether it's an image or language, in a way that is inspired by the architecture of the human brain, the human neural network originally. And it performs incredibly well, so that it'll it learns to latch onto things that are the core of a face, or the core of Chuck's face specifically, so that if he's wearing a hat, it's okay. If he's wearing sunglasses or turned to the left, it's okay. And the algorithm at play there specifically is called a convolutional neural network, a convnet. But this stuff wasn't possible nearly as effectively pre-deep learning, the current era that sort of started in 2012. And now things are just blowing up in deep learning, including image recognition.
So this is all interesting stuff, and it's okay, we can do all these things. But for me, for a programmer, it's okay, I want it to be able to start recognizing images, or I want to be able to have it start learning how to play Go or chess, or maybe I have some other algorithm where it maybe I want it to follow my grandparents around and figure out what they're likely to need next, so that it can anticipate their need. Maybe they're disabled or something. So we get to these problems that we want to solve. How do we start solving them? How do we know where to go from there?
That's a good question. So there's machine learning, I think, has been applied widely across many domains. Machine learning has been around since the 1950s. Mm-hmm. So statisticians and theoretical computer scientists and stuff have been cracking at any number of problems you could imagine. So I would suppose you would just have to Google machine learning algorithm as it applies to some specific domain. So, for example, like I said, deep learning applied to images, the algorithm at play is convolutional neural networks. Deep learning applied to natural language processing, like processing any sort of text or speech, you'd use a recurrent neural network. And so there's various twists on kind of core algorithms that make it more applicable to certain domains. You just have to have a little bit of domain knowledge and do some research.
That makes sense. I think we also hear a lot about AI kind of taking over the world, or, I think I heard one person say basically, we're going to be their pets.
Did you see the AI itself say that? There was I don't remember who it was modeled after, but they modeled some chatbot built into an actual physical robot designed to look like some specific author. I can't remember who it is. And they just let it go from there using NLP tactics. And the person was verbally conversing with it, and it responded at some point saying, I like you. When I create my human zoo, I'll treat you nicely, or something like that.
That's so horrible.
And the person looked really terrible. The recipient was laughing as he was surprised by various things the robot said along the way. But when he said that, he was like, oh my gosh, cut the interview, cut. Turn this thing off.
That kind of reminds me of the whole drama that happened with the Microsoft AI bot. It started going like racist and saying some really bad things on Twitter.
Tay, Tay,
Yeah.
The way machine learning works is you build an algorithm that learns, and now it has to learn on something. So you have to come up with data from the internet. They call this is the the big data stuff. Whether it's medical records or, what's called corpora, like giant gobs of text, like Wikipedia, so you can train it on language tasks. And that one was Tay, they basically just released it untrained into the wild. And the internet is not a nice person. And so the machine learner, jerks out there knew exactly how to hack the thing. Just start saying things that are bad, and it'll pick those habits up. And they actually just released like an answer to that, like a Tay version 2. It's got a different name, and it started doing the exact same thing. Oh, Microsoft, dear Microsoft, your heart's in the right place. So one other comparison. So machine learning, versus programming. So programming is statically programming things to do things specifically, like if-else clauses, or a user clicks a button, something happens. Whereas machine learning is like is any sort of fuzzy programming situation. So if you're trying to predict the cost of a house in some city, you can't program that with if the number of bedrooms is this and the number of bathrooms is that and. It would be too big. So you say learning algorithm, you go learn what kind of makes a house pricey or cheap. So any sort of fuzzy circumstance in programming, you use machine learning. That's kind of where you choose machine learning. So that's versus programming. And then versus AI. AI is kind of the whole of these simulated mental tasks, and probably the most important of which is machine learning. And then versus data science, people hear the word data science a lot. Machine learning is a subfield of data science. So data science is, programming tasks related to anything involving data. So if you're a database administrator, you're in data science. If you're doing charts and graphs and analytics, you're in data science. Well, machine learning is using data in order to do things, in order to learn how to do or say or see things. And so because it's consuming data, it's also a subfield of data science. So a lot of times if you're looking for a job in AI or machine learning, you might, broaden your search term to data science as well.
So it's kind of funny that this episode came up because, I just got word from my dad that my aunt is coming to visit soon. So I've been trying to think of how can I make some kind of translator tool, because she's from Japan. She does not speak English, and she's coming to visit me. I don't speak Japanese, and I only speak English. So, we have Google Translate and stuff, but I really want some kind of thing where I can put on a headset with speakers or with a microphone and then be able to talk into it, and it translates, and then she hears it on her headphones in her natural language. So I guess that would be some kind of natural language processing to convert it over into some kind of text and then be able to translate it and then speak it out into another language.
That would be super slick. I think there's actually a product in the works. I don't know if it's finished yet, but I've seen something similar, like a Bluetooth earpiece that does translation. I think it uses Google Translate behind the scenes. You can build your own speech recognition and machine translation system using recurrent neural networks and a model called Deep Speech 2. But Google's Translate is the best you're ever going to get, and they're keeping their models for machine translation secret sauce because that's one of their heavy hitters. But yeah, you could use their speech API. They've got a cloud API for various of their machine learning models out there that you can just call. But that would be really slick if you could build something like that.
Got to bust out the 3D printer and my old Raspberry Pis now, right?
Nice.
Yeah. I think that's something that people hear fairly often too is, oh, well, I'll just get a whole bunch of Raspberry Pis or Arduinos or, whatever, and I can just hook this up. And then other people have the idea that you have to go spend a gazillion dollars on AWS in order to make this work. So how approachable is it?
So that's a good question. AWS is very expensive. I've deployed machine learning models that, the type of instance you're using is called a G2 2x large or a P2 instance, and they're very expensive by the hour. By comparison, Google has a hosted solution, a competitor, and their hardware is not GPUs, they're called TPUs. I don't know what it stands for. And they're specifically dedicated for using TensorFlow. I don't think it's TensorFlow processing units, but it's specifically dedicated for using TensorFlow, which is Google's deep learning framework. Very fast, very cheap by comparison to AWS. I imagine if you're going to build some small device that doesn't have a lot of computing power, you'll probably be doing it in the cloud by way of Google's cloud service in TPUs. Although TensorFlow has the capability of deploying your machine learning models to a physical device like a mobile app or whatever. I think of TensorFlow as the React of machine learning, because you've got React Native, you have TensorFlow can go on mobile. And it's kind of that same concept where it's a high level framework that does most of the heavy lifting for you. I don't know actually what they do for these smaller devices that don't have a lot of compute, like Raspberry Pi. It's a good question.
And then as far as the algorithms go, again, it seems like, I don't know, when I came up in programming, it was, basically what you called programming, essentially where it was, I'll put in all the if statements and it'll do the thing. And, now I'm teaching this machine how to teach itself. And so what are some of the approaches to that? I took an AI class actually in college, and so I understand some of this, but it wasn't machine learning. It was specifically like Bayesian algorithms and things like that. And so it would essentially evaluate where it was at periodically and then just make a decision. And it seems like machine learning is kind of on another level with that.
Yeah. So now we're getting deep. Those statistical models that you learn, like Bayesian inference and such, versus machine learning, there's a really fuzzy overlap between the two. It took me a really long time to figure out the difference between sort of Bayesian probabilistic models and machine learning models. So I think for our, the listeners that are not exposed to machine learning, that distinction, pretend it doesn't exist. Statistics and machine learning are basically the same thing. And so that's the crux of it, is instead of programming procedural code, you program statistical equations, you program math. So you have a 5-liner that is straight from a statistics textbook. So it's a huge leap from programming. You look at it and it's maybe, 5 to 100 lines of code, maybe 200 lines of code for one of these really capable models. And you're like, okay, well, I know code and it doesn't look like a whole lot, but you're going cross-eyed as a programmer if you haven't, deep dove statistics and calculus and the sort, because you're not programming lines of procedural code, you're programming math. And so a lot of these frameworks like TensorFlow and these libraries like scikit-learn and NumPy and stuff, they have as method names mathematical equations. And you're working with matrices and matrices and vectors and all these things. So, that gets into sort of the qualifications of becoming a machine learning engineer. Traditionally people would have a PhD in theoretical computer science or statistics or artificial intelligence or machine learning or one of these things. And now, because it's becoming so popular, every company in the world wants to get their hands on it. More jobs are opening up to just your average Joe. But of course, not just an average Joe. You typically at least have to have a bachelor's degree in computer science or the like, and more they're liking to see a master's degree. But I've done a lot of interviews on just my piddly bachelor's degree, so I've proven that you don't actually require a master's degree to start cracking into this space. But you need to know math. You really need to know math. The 3 branches of math you have to be good at are linear algebra, calculus, and statistics. And specifically, statistics is just really, really important in machine learning.
Oh, I feel better now. I only failed 2 of those classes in college.
You can get started though without any. You can really start building things without any math. But it's kind of like learning machine learning without math is like learning React without knowing JavaScript and without knowing, the nuances of JavaScript, you can do it. And I would recommend even trying it. It's not, I'm not bashing that approach. It is a worthwhile approach, even just to start, getting your feet wet and feeling the lay of the land and feeling like you're accomplishing something. You can build machine learning models with just knowing TensorFlow and some Python, not knowing the math and the fundamentals. But eventually, you need to know the fundamentals, and that's going to be math and, of course, Python and all that stuff. But more and more people are self-teaching machine learning and then cracking into the space. It is it's tough to learn. It's unlike web development and mobile development, where you're seeing this huge surge of boot camp graduates in a 6-month program, like hitting the ground running. That won't be the case with machine learning, unfortunately. You'll build your first model in 2 to 3 months, but then you're going to need to learn the real foundation over the next year before you can start applying to jobs.
Interesting.
But so now I want to talk about why should you care then if you're like, okay, this sounds hard, and like why I'm a Ruby developer, I'm a JavaScript developer, why would I care to do that then? Why not just stick to my guns? And there's multiple reasons. One is that the next, this is the next wave of computing. This really will displace jobs. There's a lot of fear that, for example, self-driving cars is going to displace truck drivers and Uber drivers and taxi drivers and all those things. And that is true. That is actually true. And so something's going to give eventually. We don't know how this situation is going to pan out, whether it's going to be minimum basic income or universal basic income or what. But in the medium term, we as programmers really should have an eye towards machine learning, learning machine learning, because already recurrent neural networks are spitting out code. It's trained on all of GitHub and the programs that those repositories produce. And it starts to learn how to write code. And a lot of these models, they don't work fully. They generate broken apps and stuff. But they're working on this already. We've got logo generators using artificial intelligence. And so the thing about AI is a lot of people think it's like the really, it's going to be this data from Star Trek, like really mathy, and it doesn't, it cannot compute humor, cannot compute art. But that's not true. AI is generating art that is indistinguishable from human art. They do these Coke versus Pepsi challenge on art, human art versus AI art. Nobody can tell the difference. It's generating music. It's generating poetry. It's making logos. It's making website designs. Wix.com is working on AI generated websites. So, don't start pulling your hair out yet, but you don't have to be afraid for quite some time, but it is something to keep an eye towards.
So if a robot or a computer program or AI is able to start writing its own code, at what point would it be able to overwrite or basically nullify the 3 laws of robotics?
That is a good question.
Well, we just went right to sci-fi.
Dear Ruby developer, are you sick and tired of working on crappy old legacy code bases? There's got to be a better way. If you want to get a better job, here's what you can do. Find a technology that's really in demand, build a side project using that technology, and then use that side project as experience to get your next better job. I've done this myself several times. It definitely works. What I think is a really good technology to learn right now is Angular. Angular is really in demand right now, and it's not going away anytime soon. I have a free guide to getting started with Angular and Rails at angularonrails.com/rr. Good luck and enjoy this episode of Ruby Roads.
Well, let's go to sci-fi. So, there's a guy named Nick Bostrom who wrote a book called Superintelligence. So Nick Bostrom wrote a book called Superintelligence, which was just grasped onto by huge names in the industry like Bill Gates and Stephen Hawking and Elon Musk. And these guys started, I don't remember if you guys saw that. There was like a wave where these guys were screaming, the end is near. And everyone believed it because these are big guys. it's important to remember they're not artificial intelligence experts or machine learning experts. They're experts in their own field, but they're respectable minds. I'm not a believer that this thing, that you're going to get evil killer robots, runaway evil killer robots. AI is too hard to build, to just get a runaway thing. You have to be very mindful as you go through the process. But I'm afraid of job automation, of job displacement. I'm not afraid of evil killer robots, but that's a fear that's being discussed right now. And then then you can go down this giant rabbit hole of sci-fi, this thing called the Singularity by Ray Kurzweil, where runaway technology causes an exponential explosion in technology, and the rest is history. You don't even know what that even looks like. And the thing is that these crazy sci-fi discussions on AI, they may or may not hold water. They, various aspects of these conversations have merit, and various aspects don't. But the point is that these are not like tinfoil hat conversations. These are things that are potentially legitimate concerns. I think so. A lot of people get into the space of AI and machine learning because there's a lot of like almost metaphysical inspiration surrounding this stuff. Like there's some crazy possibilities surrounding this technology. And the piece that I'm the most interested in is consciousness. There's a huge philosophical conversation about whether, where does consciousness come from? Is it an emergent property of the human brain, or does it have to follow some specific architecture, neuronal architecture? And if that's the case, is what we have with deep learning and neural networks enough of a representation to be a functional approximation of the thing that generates consciousness? And, or is consciousness a byproduct of computing machinery in general, which is called the computational theory of mind? And there's this huge philosophical debate that's happening right now. We have some people on the left and some people on the right saying, and PhDs on both camps saying, AI may or may not achieve consciousness, which is like, whoa, you're going to, create a soul. That sounds ridiculous. But the point being that there's a lot of inspiration, not just fear for jobs, not just interest in solving big problems, but true inspiration driving people into this space.
Well, and it's interesting. I mean, the moral issues aside, right? Are they going to be dangerous? Is it going to hurt people? And those kinds of things. The thing that I'm really interested in, that gets somewhat close to consciousness and, a soul or not a soul is, are we going to be able to tell, right? It's kind of the Turing test, but it's the Turing test at a different level, So instead of just having a chat bot, it's going to be actual, I'm going to talk to my Amazon Echo, and I'm not going to be able to tell that there's not a person there handling my problems, right? I'm not going to get I don't know what you're talking about. It's just going to, it's really fascinating to think that we might get to that point, where my doctor might be a computer.
And you won't be able, you won't be able to tell the difference. You won't be able to tell whether you've achieved the thing. That is exactly the Turing test at play. Yeah, and that's why it's so philosophically impossible to solve that question.
And all of this machine learning and doctors reminds me of, if you've ever seen Idiocracy, when Luke Wilson goes into the hospital, he has to plug in those 3 probes to, figure out what's wrong with him. And it, I guess, just gathers a bunch of data to say, probably, here's what's wrong with you. But it was a funny scene. If you've not seen that movie, go watch it. It's pretty horrible.
I haven't seen it.
It's one of the funniest movies ever.
What movie was it? I lost a little bit of that.
Idiocracy.
Oh,
basically, where all the dumb people outbreed the smart people.
Yeah, but the thing, I mean, you talking about that at the same time, it's also interesting just from the sense of, we unleash machine learning on something like medicine, right? And so it starts figuring out, maybe diabetes isn't what we thought it was, or this treatment doesn't work as well as, because the doctors, they get swayed by all kinds of things like drug reps coming out and taking them golfing and stuff like that. And, you have this computer that just isn't, but at the same time, if you have a computer that is acting at that level, in some fundamental way in people's lives, what about security? What about it getting hacked or things like that, so that you give it a bias toward a particular product or drug or something like that? I mean, there's this whole other avenue of this that becomes really, really interesting all of a sudden, because it's like, you know what, we want to hand this off so that we don't have to think about it, or so that we can, have something that's not as biased or not as, biasable, I guess, in certain ways. And of course, the programmers are going to build some biases in, because that's just the way that it works. But, even without thinking about it. But at the same time, it's just, it's really interesting just to see where all this goes. And then, how do we make sure that it's best serving us, or in my case, me, and in your case, you, if we want to be served differently.
That's right. Exactly.
So if people want
all that stuff.
If people want to dive into this and they're like, okay, this sounds like something that at the very least I need to know something about, even if I'm not going to go and be an AI or machine learning developer, where do they go?
So I created a podcast called Machine Learning Guide, and I'm not just self-promoting this over other resources. There actually was a void in sort of like really high level lay of the land in my experience, and definitely in audio format. So I'll link to that Machine Learning Guide. So it's going to go A to Z. It's going to introduce the topic, the inspirations, compare, a lot of the stuff that we talked about in this episode in more detail, and then actually start introducing algorithms and the math you need to know and certificates and degrees and stuff for consideration. But importantly, it's going to give you a curriculum of, step one, start with the Andrew Ng Coursera course, for example, which is the very famous introductory resource for machine learning. But then step two, because Andrew Ng's course doesn't kick you off into the next step. You have to know what comes next. Step two is going to be, read the deeplearning.org book or something like this. So I lay out a curriculum in the Machine Learning Guide podcast. There's also a book called The Master Algorithm, and that's another really gentle lay of the land, layman's introduction to a lot of the models. And it's in audiobook format too for the audio people. And like I said, the Andrew Ng Coursera course is the premier starter course.
Nice. I actually signed up for that course, and then I didn't have time to do all the homework. So, but the videos are really good, and he explains things really well. So, yeah,
he's an excellent teacher. And, so you mentioned before, this is a Ruby podcast, and I'm going to, talk about this topic as well in the JavaScript podcast. Two different languages. The language for machine learning is not Ruby, and it is not JavaScript, unfortunately. I'm a JavaScript developer. I want everything to be JavaScript. I'm a huge fan of React Native, a huge fan of Electron, all those things, but don't do it. The language of choice for machine learning is Python. So you're going to have to, Python is so similar to Ruby anyway. I think it won't be that big of a transition for your listeners. But there's various languages you can use. You can use C++ and C. You can use Java. You can use R. R is a little bit more popular amongst the data analytics, data scientists. Java for enterprise. But far and away, Python is the king language of machine learning. And it's not because of the language itself, it's because of the tools and libraries that are built on top of it that are industry standard at so many companies. The main framework being TensorFlow, and scikit-learn is a little library under that. There's competitor frameworks. There's one called Torch. There's one called Caffe, and so on. But they're anybody who's anybody in the machine learning framework space is on Python. They do have Ruby machine learning repositories, same for JavaScript. There's something called brain.js, but these are really just kind of like proof of concept, playing around stuff. These are not deployment ready machine learning repositories or anything like that.
Yeah, and just to pile on here, so we have Jordan Hudgens, who was on a couple weeks ago, coming to Ruby Dev Summit, and he's going to be talking about machine learning in Ruby. So if you, I think there are two levels to this. There's the one level where people are like, you know what, I want to learn this, and I want to learn it the way that people do it. And so, go take the course, do it in Python or R or whatever they're teaching in the course. or in the book. There's a terrific book out there too that's I think it's machine learning or artificial intelligence in Python. I don't remember. I'll put a link to it in the show notes. But I bought that on Amazon on my Kindle, and it's pretty darn good too. But I think there are other people that, you know what, they love Ruby, they want to do all this stuff in Ruby, and you can go and use those libraries in Ruby. Just keep in mind that some of the examples you're going to find on the internet as you try to convert them to Ruby aren't going to go as seamlessly as you wish they would.
Right. And well, a big issue with with Ruby and JavaScript, for example. So yeah, that would definitely be awesome to play around and get your feet wet and stuff like that. But one of the primary concerns is that what Python does is it in TensorFlow drops down to C and executes code on the GPU for performing matrix algebra, which is essential for deep learning framework, deep learning models. And so you're able to get like 100 to 1,000x speed improvement using using Python's frameworks over vanilla, hand coding the math in your language of choice. So it won't suit you well for deployment to many users, for example, that wouldn't need to use the system. And so a lot of researchers use C and C++ so they can actually custom code their matrix algebra and their mathy stuff on the GPU themselves. But you're not. None of us are going to be doing that stuff. So you just depend on TensorFlow for executing your math on the GPU in a very efficient way, and that's one of the big boons of using one of these frameworks. And it's substantial. I don't know if you guys do Bitcoin mining or gaming or anything, but I've got my 1080 Ti in a
Ethereum mining.
Yeah, and it's like the mining on the GPU goes, I think, like 300 times faster than my CPU, and so it's just not even worth turning the CPU on for the mining. And that's the case for machine learning. It's like you need to use one of these frameworks because you need it to execute on the GPU because you need 300x speed improvement.
Yeah, I was mining Bitcoins back before GPU mining was even a thing. So it was all CPU mining. Then GPU mining came out, and I got a pair of 6970 Radeons and mined for a bit. Then when Bitcoin shot up in its price, it was like $1,000 or something. I sold them all, and bought some new toys.
Nice.
I should have held on to them.
Is it profitable for you? Are you making some money?
I was back in the day. This was maybe 8 years ago now. So,
wow.
Yeah, I was an early. I say early. It was out way before then, but I was an earlier adopter of the whole Bitcoin scene. But then, the farms came out, and I'm like, you know what? I cannot afford this. This is just crazy. So
right.
I stopped.
It's like not worth the electricity sometimes.
Yeah.
Yep.
I have a ASIC miner in my basement, just unplugged, not doing anything, just because the hash rate is just way too high right now. So.
Yeah, we're in a spike. It looks like it's coming down pretty hard too. I would say 8 years is an early adopter. That's profit status in my book. I didn't even hear about Bitcoin until about 5 years ago.
Yeah.
That's crazy.
Way back then, I told my wife at the time, like, I really, if I could just invest a couple of grand and buy a bunch of GPUs and do this, it will so pay off. And, that decision never came to fruition.
Oh, bummer.
What a shame. Oh, well.
All right. Well, is there anything else that we should talk about with relation to machine learning?
No, I don't think so.
All right. Well, let's go ahead and do some picks then. This episode is sponsored by Compose.io. Compose is a fully managed database hosting with extra security, scaling, and performance. Hosted on dedicated SSD servers, you can pick from 9 highly available databases: MongoDB, Elasticsearch, Redis. Compose Enterprise comes with easy scaling, which means you can add additional nodes at any time. It's auto-scaled resources like storage, memory, and IOPS, RESTful APIs, Central Console to manage all your deployments, and premium support with guaranteed response time and priority ticketing. With Compose Enterprise, you can free up your time to focus on building your app instead of managing your database. Check them out at enterprise.compose.com. Dave, you want to start us off with picks?
Oh, geez. I just took a week off of work, so I bought some more power tools.
Good way to spend your time.
I know. I really need to stop working with my power tools because that's been all my picks lately. But I ended up returning the 8-gallon compressor and getting a 20-gallon compressor. And holy crap, that thing is amazing. I got a really long extension cord for the air hose, and I was spray painting my fence the other day. I mean, it is just amazing. I'm not one for manual labor. I'm not really good at it. So anything I can do to cut corners but still get a good result, I'm all about. So it's a Husky 20-gallon air compressor, oil-free, pretty awesome.
Oil-free?
Yeah, it's an oil-free. So I don't have to change the oil or maintain it. But I guess that means it's a lot louder and it's not as strong. So it doesn't have the horsepower to really charge it up quick. It takes about 5 minutes to fill up the 20 gallons.
Okay. I just didn't know that they made them oil-free.
Yeah, a lot of the pancake ones, the little small 6 gallons, are oil-free.
Okay. Yeah, I just have gotten used to looking in the sight glass and going, oh, it's low in oil. Yeah. All right. So I'm going to jump in with a couple of picks myself. One of the things that I've been doing lately has been managing my Twitter account, just, who I'm following and stuff, so that my Twitter feed isn't full of a bunch of stuff that I'm not really interested in seeing. Twitter for me is more of an at a glance, get information or news. And, and then some of the other places that I look are places where I get more in-depth information. So yeah, I've been following some people and unfollowing other people. One of the things that has made that really easy is the T gem. So if you want to just gem install T, it has a whole bunch of Twitter tools built into it. It's pretty nice. It's a command line utility, but I really like it. So I'm going to pick that. And then I'm also just going to remind everybody about Ruby Dev Summit. If you're wondering about cost, it's free. And if you're wondering about travel, it's online. So there's really no reason not to sign up. If you sign up, you get free access to the talks when they are being streamed. And then after the fact, if you want access to the recordings and stuff, you can pay for an all access pass, which is going to be $100. And I'm going to send an email out to the list and stuff like that. One other thing that I'm also going to mention as a pick, and it's everybody's going to be like, yeah, we all use it. But I've been on this kick lately where I've been doing just automation stuff. And the more stuff I automate, the easier my life becomes. And one of my go-to tools is Rake. And so if you're looking for some automation, just Rake. Ruby, you can write a script and then you just, Ruby and then the name of the file. But, sometimes it's nice just to have a Rake task with a name that you can just drop in there and have it do its thing. So yeah, between the two, I'm really impressed with Rake. Tyler, what are your picks?
Cool. So Machine Learning Guide podcast and Andrew Ng Coursera course are going to be your starter packs for machine learning. But if you want some inspirational oomph, my favorite resource is a course by The Great Courses called Philosophy of Mind, Brains, Consciousness, and Thinking Machines. And it's all about whether robots can be conscious. And it's taught by a professor at a university. I mean, it's a course, so it's actually some legitimate material. It's not quite Ray Kurzweil level stuff.
Nice. All right. Well, if people want to see what you're working on now or follow you on Twitter or anything like that, where should they go?
Probably GitHub is LEF and IRE, LEF like Frank, and IRE. Same with Twitter. I don't have a whole lot of activity on my social networks, unfortunately, so I wouldn't bother going to either of those locations necessarily.
All right. Well, we'll go ahead and wrap this show up. I encourage people to go follow that and check out your podcast, and we will catch you all next week.
Cool.
Great.
Thanks, Chuck.
Talk to you later.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.